Okay, so in this video, I'd like to take a look at the poetry problem, and we're using it's a CCC problem, but it's also on the DMOJ judge, and this problem is a challenging problem. It's certainly challenging compared to the type of problems we've been dealing with in the course up until this point. Um, but it but what you know already about strings and lists and dictionaries, I think for the three problems that were been assigned, you really know the tools already that you need to employ to solve these problems. I think what these problems do is present you with a more challenging overall problem because it really consists of many things that need to be dealt with, and kind of in the overall problem solving it can be difficult to tackle these because of that fact, because there's so many little things that have to be dealt with. Even just reading the problem is challenging. So I think, I'd like to try to outline the problem, kind of aspects of different problem solving techniques. This is the point of these problems, is to try to kind of get to that next level of being able to apply what we know about programming to these more challenging types of problems. So the first thing I think you have to do, obviously the first thing you have to do, is you really have to read the problem and know what's going on. So please, at this point, I think the best thing for you to do is to take a moment and whether that's pause the video, read through this, and try to, as you're reading through it, try to, with pencil and paper, try to make a list of some of the things that you know are going to have to happen in order to make this problem, in order to make it work. And so hopefully you've come back, you've done that, you've had a chance to read the problem and think about it, and you've got some notes in front of you. And I think that's a really crucial step, and so much so that I will try to mock it up doing this. This is not going to work very well, I can tell you that. But eventually I'll find something that works a little better. I'm trying to draw with the mouse. So I'm going to read through it and try to pull out the important stuff. And I will flip back to the browser if that's okay, because the test cases, which are down here, are really important as well. And I could not fit all of those things onto the screen at once. So I have the description there, and I have some test cases here. The test cases are kind of the example inputs that you could run, and the example and the outputs, of course, that you should get when you run those. Okay, so this problem is called poetry, and is about looking at poems that come in, and this is an example of one of those poems. The poems come in, and it says here they are consisting of one or more four-line verses. So I'm just going to make a note of that. We have, and I'm already on the wrong tool here, so I'm going to, I was using this last time. So 4-line verses, and 4 lines, so it's 4 lines at a time. Each line consists of one or more words consisting of upper or lowercase letters, or combination of both uppercase and lowercase. So what do you think they're telling us here? I mean, we'll have to keep going to kind of understand maybe what the importance of that is. But we'll just make a note of that. There's upper and lowercase. Adjacent words are separated by single spaces. So we have a line that consists of upper, there's an uppercase, lowercase, and the words are separated by spaces. So upper and lowercase, which I probably can just use the text tool as well at this point, but this is this is not what I was wanting to do. I had done it on paper, and I couldn't get the cam and everything to work together. Yeah, that's terrible. So I'm just going to keep going. So adjacent, so we're going to look at this. This first paragraph is about how to deal with the lines and get words out. Define the last syllable, second paragraph, the last syllable of the word to be the sequence of letters from the vowel. So these are the vowels, and this is important, but not why. So to the end of the word. If a word has no vowel, this is a special case, okay? So the really important thing that we can take out of here is that we go from the last vowel to the end of the word. So for instance, when we had the word small, the last vowel to the end of the word, small, small. This, you only can read it because you heard me say what it's supposed to be. We have to find the last vowel, and then we have to use that and anything else that is in the word to find out what the last syllable is. What does this look like? Does this look like, other than totally, total badly drawn stuff? This should remind you of something that we've dealt with in a string, and that is that we can take a section of a string. If we know where we want that section to begin, we can easily take a section of a string by using a slice. So this is going to be a slice. And the key thing to this is going to be when we find this last syllable thing, which is probably going to be important. We can see why coming up. But we need to be able to figure out where the last vowel is. And how are we going to do that? Well, that is maybe a problem that remains to be seen. But I think we've got two important tasks we have to do. This, I think, is going to be number one. I'm going to say that that's task number one. And this is also a task up here. I think what we're really getting at here for this whole first paragraph is how do we get the last word? What we really need is the last word. How do we find out what the last word is? And how do we make sure that it's not going to be messed up? We have to do some matching later. We're going to see that in a moment. But how do we find out, what the last word is and make sure that it doesn't have any uppercase in it? We've dealt with this before. We can use the lower method. I think you'd be familiar with that. So this is going to be problem number, subproblem. These are going to be subproblems. This is subproblem number 2, extract. Obviously, I really need to extract the last word before I can pull out the syllable in terms of actually doing the problem in the end. But I'm not really trying to do the problem from start to finish in a kind of like, okay, well, now I'm going to start coding, and the first thing that's going to come in is this, and then I have to process it this way. I'm not doing that. What I'm really doing is trying to find problems within the problem, smaller problems that I can solve, test, make sure they're working, independent of running it on the judge. Just get the pieces working, and then I can put them together. So it's okay to tackle this syllable thing first and deal with the last word problem second, because I'm not trying to put it together yet. Okay, so if word has no vowel, then the last syllable is the word itself. This is a special case of the syllable thing. We're going to need to remember to test this and come back to this to say whether that is in order to deal with that. Last line says we say that 2 lines rhyme if their last syllables are the same, ignoring case. So there's that case problem. So if we have 2 syllables, and if we go back to this, so this syllable here for small is A-L-L, and the syllable here for tall, last vowel A to the end, all and small are the same. All and all, in this case, the syllables are the same. Therefore, according to this, small and tall rhyme. Okay, so that's why we're doing this last syllable thing, because we're looking to see if they rhyme. And if they rhyme, the whole point of the output of the problem are these things. They're kind of, highlighted because they have to be exactly that. And remember, it's a judge. You can't spit out perfect with a capital P, or spelt incorrectly, or, with something else tacked onto it to say the poem is rhyming scheme perfect, right? That would, any of those examples would be wrong. It has to be exact. If the output is expected to be perfect, then that's all the judge can see is the exact word perfect. And remember, that includes prompts. So when inputs come in, we don't put any prompts there because that is a form of output as well. So we have to say either, we have to say one of these 5 options, and the 5 options are described here. So the first option is, excuse me, that 4 lines in the verse all rhyme. I think we will come back to this. We already have some work to do here. I guess we should keep going. But you can imagine if we grabbed the problem here, this one here, you could imagine that what we're going to have is all and OT and OT. So that would be our number 1 syllable be all, number 2 syllable would be ought, number 3 syllable would be all, and number 4 syllable will be ought. So this is test case 1. Okay, and so let's look at the sample input 2, just for something to compare it to. And we have the last words are boo, boohoo, to, and foo. And just thinking about this for a moment, back to here, we have to find the last vowel. So in the example of boo, we would have to find the last vowel and then go to the end. Last vowel and go to the end. Obviously the last vowel is this O, and it is the last letter. So in this case, boo, boo would simply be O. And it's the same thing here. The last vowel is an O, and from the last vowel to the end would just give us an O. The last vowel to the end of to would give us an O, and the last vowel to the end for foo would give us an O. So that would be the rhyming scheme there. This would be the last syllable, I should say, in each case. And then what we need to do in both of these examples, we need to examine and compare, the pattern to what these are. So starting with this one here, because the syllable is just the letter O in all 4 cases, they all match. So that is a perfect rhyme. This one, if we think about these as, now normally if we put these in a list, we would think of this as index 1, but in the question they're saying the first 2 lines or the first and third line. So they're really thinking of numbering things starting with 1 rather than 0. So if we do that, what we can see for our first example up here is that we rhyme with 1 and 3, rhyme and 2 and 4. So we're looking for 1, 3, 2, 4. So this is cross. We're thinking that this is cross, and we're thinking this is perfect. So when we come back here, we see that this is cross, that's correct, and the first 4 lines here is perfect. So we seem to be on the right track with this. And if we were to, I just mentioned a list, if we were to store these into a list, it would give us a very easy way of using some if statements to extract that. Or we could just, it's only 4 things, so we could just use 4 variables as well. There's no reason why 4 variables wouldn't work equally as well. Maybe just called, first, second, third, fourth. And we would just check with an if statement. If first equals second equals third equals fourth, well, that's a perfect rhyme because they're all the same, and that's what the problem said. And there's just combinations of that go through to down to free, which is the case where none of them rhyme. The way they're putting it, it's none of these. It's neither perfect, even, cross, or shell. So it does not, it is a free rhyme. There could be a rhyme in there, I guess. Like the first 2 could rhyme, for instance, but not the last 2. And so that wouldn't be even. and first two don't work for cross or shell. So that would end up being a free rhyme. So there could be a rhyme in there, but it just doesn't match any of these patterns. Okay, so I think we've kind of we've dealt with, so this is subproblem 3. I'm going to call it subproblem 3. If we have a list of the variables of the syllables, sorry, or 4 variables of the syllables, can we compare them and determine the rhyming scheme? And I think everything else is about reading a bit of input. So we'll just deal with that as we come to it. Let's look at problem number 1. Slicing out the last syllable, and we'll work with this word small, and we'll work with boo. Boo's a good one because it's this example where there's a vowel at the last one. And do we have an example of no vowel? Because that was something as well. I don't see a word here that has no vowel, but we can kind of expect that will show up in one of the test cases, because it was mentioned in the problem statement. So we'll just toss some kind of word that has no vowel. It can have a Y, but it will have no vowel. So whatever that word's going to be. So let's look at that. So last syllable. So, and in the end, I think that this is going to be a function, because that's going to be the best way to tackle it. But it's not the best thing to do in this case, because it's going to require that we the problem with starting with the function is that it's difficult for us to look inside the function and inspect it as we write it, because it's all local scoped variables. So I'm not going to start. I'm going to turn into a function afterwards. Okay, so the word is small, and we want to find the vowel. I don't know if you recall the keyword in. So if we can make a condition using the keyword in. It's called testing for membership. It simply asks, is this thing, does it appear in this word? Okay, so if we ask if an A appears in the word small, then we get a Boolean back, Boolean true, and if we ask for B, it's a false. So this is a really great test. It's kind of like, okay, so we kind of just said, is A in small? Okay, and what we actually want to do is we kind of want to go through one letter at a time. So if we're going through small, we want to find out if S is actually a vowel. So we can kind of go the other way if we think about it kind of in reverse. A, E, I, O, U, those are the 4 vowels we're supposed to check. That's what the problem statement said. So if we were looping through small, starting with the letter S, and asking, is that a vowel, we would find out that it's not. M, we'd ask if it's a vowel, it would say no. And then, of course, A, it would say true. We would find the first vowel. We just went forwards, though. That would find the first vowel because we start at the beginning. What we'd really want to do is start at backwards. We want to start the back last letter and work towards the front. So that sounds like a loop to me. We're trying to iterate through the word. But unfortunately, we're not going forwards, so it's not as simple as just doing for letter in word. We have to actually construct our indices, our index variable. We have to actually construct it using our range statement. So, and we've done this before. This is just going to be one of these ones that has a step of -1, so that it goes backwards. What's the index of the last letter in this word? Well, in this case, it's 0, 1, 2, 3, 4. It's 4, but it changes every time we throw a new word in there. It's the length of the word, which is 5, -1. So that's the start index, the last index. And I know that we've covered that. So that's something that I feel like you could stop the video right now and maybe start writing this code for finding the last vowel. I think that would be a good thing to do because I think we've kind of got to the point where we're right where we were with what we know in this course. So please do that. I'll continue just so we can kind of work together in a way. But so I'm starting at the last one and I'm going to the first one. Now, and you remember we go up to but not including. So if we go to the first one, which is 0, we actually won't go to that. If we make end index 0, we won't stop there. We'll stop up to but not including. We'll stop at m. So we want to go say that the end is -1 so that it goes up to 0 as the last one. You know what? You should just test this. It's not a crazy idea to just run that and test it. Off by 1 errors are super common. It's not, test it again. Just print out what is the actual thing that appears at that indice. If so there's the word coming out backwards. This is correct. We know this is right. And if we throw another larger word in it, we know it's working. This testing is really essential. What you don't want to do is start dealing with these problems after you've written 50 lines of code to solve the entire problem, or even just 15 lines of code, and then have this problem buried in 15 lines of code, and it's nearly impossible to find it, and especially when it's combined with another bug in your code. And then you're staring at a screen and getting super frustrated. So this is I feel very strongly that these problems are difficult mostly just because of the process that students tend to follow to solve them. Testing is really important. Subproblems are really important. So those are the two things we're trying to deal with. Okay, so let's just try to get to the actual task at hand, and that was if the word, whatever the letter at this index is actually A, E, I, O, or U. Is it in there? If it is, this I is the thing, it's the really important number, right? That first one, we can even break the loop at this point. We can break it because we found the number that we want, right? So if I run this again, it stops after seeing the E, which is 0, 1, 2, 3, 4, 5. That's index 5, and it stopped, and it printed out a 5. Okay, so that's the right thing. And this would be 0, 1, 2. We want to see a 2 in this case, and that's printing out the 2. Okay, so that's working. And what about boohoo? We said that was going to be a problem. Or 0, 1, 2, 3, 4, 5. We want a 5 again. All right, and what about a variable or a word that has no, nothing? It's the whole word. So what we really want to do is know what it didn't print I. At this point, I is actually a 0. Let's slice. We haven't done the slice yet. So if we were to ask for, let me go back to smaller. Now we have the word, and we are trying to slice it from the last vowel on. So that is the syntax. I don't need to put anything here, nothing there. That means go to the end. Start at index 5, go to the end. Okay, so that's working. And same thing, so start at the index and go to the end. And that's working. And in the case of, a word that has no vowel, I is what? It's 0. Well, that just start at the beginning and go to the end, which is the word itself. If you counted that, that would be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. It's the same. So this is working. This just needs to kind of like, what syllable is equal to word index to the end. Okay? And that is going to be what we need to, and then I'll break it. You know what? I won't even break. I'm going to turn this into a function now. So we don't need to print anything. That was just for tracing. And we don't need to, this is going to be last syllable. We're going to pass in a word. It's going to be locally scoped. All of this gets indented. And in the end, we are going to, Not sure why I'm getting the squiggly line here. We're just going to return, oh, because it return that syllable. And oh, sorry, no, I do want to keep the break. I want to be clear about something here. Okay, so this conditional statement, is find the last vowel, find the vowel. And if it finds it, it stops the loop, which means I is at the right value. We tested that, okay? We printed it, it was the right value. And now we're ready to slice the word. So that's not inside the if statement. That's intentional. In fact, I'm going to pull it right back. I meant to do it that way. We broke the loop, so the loop is now over. So we're going to the point where the loop is finished. You might get caught up on this if you were, this might be something that gave you a little bit of trouble if you were trying to, there's probably many different ways to do it at this point. Not everyone is a fan of using a break in a for loop, but I think this is the example of where it actually does the job properly. So, and it makes it the simplest kind of answer. If we found the vowel, we stop searching, we have the right value of I, we create the syllable, and we return. If we didn't find the vowel, then the I index has gone all the way back to 0, which is also the right answer. We construct the syllable and we send it back. Okay? We still need to test this. Why? Well, because we just turned it into a function, and at this point, it's not clear to us that any of that stuff, the last little bit of stuff, actually was done properly. So let's start testing again. So we're testing the case with no vowel. That worked. Worked. Okay, so this is working. There really is nothing. I don't think I need to test anything else. We've really solved a really important part of this problem. We've done subproblem 1. We can slice out a syllable. Okay, so let's keep going. And the nice thing about a function at this point too is now we can forget about it. We're done. This is finished. We don't need to worry about it. If we have a problem with it, we'll come back to it and test it, but it's not really, it's not even executing. So we can continue writing code and just ignore it, because at this point we're going to find the last word. We're going to do subproblem 2, last word. So sorry for flipping around so much, but last word. We need a line of text. This good line. Get the last word out of the text. Last word. Okay, so this is a line. And let's deal with this now. We're going to start over kind of in the problem solving process. We're kind of, like I said, this is completely out of mind now. We don't need to think about this. All we want to do now is try to pull out the last word. We'll deal with, let's remember we had this special case of ignoring case, okay? So at this point we can see that there's some upper cases in here. So I don't know where you can deal with this anywhere really, but I don't know if you remember, but there is a method. There are some, this is a string right now. So if we do the double tab on the string in here, we see all the methods associated with strings. So now you don't know what these do, and I totally understand that. So you might Google a Python dictionary or Python documentation and start looking them up. Some of them are pretty, you can guess you'll be pretty close to guessing what they're doing, but you really do need that documentation. So remember we're in Python 3 because there are a few differences, and we're probably on this one. And where do we find that? These are, is this going to be, okay, so these are strings that we're dealing with right now. So am I in the right place? The documentation is not always the easiest to find. It is not. This is all the stuff we do with strings that isn't part of the string methods. So I'm sorry, I haven't been in here in a while, and my intention was to get you to, okay, this is what we want. So I clicked on the library reference, which you're supposed to keep under your pillow. Just means keep it close at hand. Okay, so, and we're dealing with strings right now. So common string operations. Please be the right one. No, we're back where we were. This is not good. String. No. String, okay, so Google, Python, string, they're called methods. Not finding it in the docs. Here we go. We're on 3.6 now. Okay, this is what I was hoping to find. These match up with those, these match up with the, capitalize, casefold, center, capitalize, center. I don't know where casefold went. And I'm going to go to lower. Okay, so not is lower, but lower, 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 lower. Okay, return a copy of the string converted to lowercase. You probably could have guessed that one, but this is important to have at hand. All right, so I just Googled Python string methods, and it told us, it gives us a lowercase version of the string. Let's just be, So the capital T is gone, but is it gone, right? It's still there. The variable line is still the original thing. The thing that we get back when we call .lower is the version without it having capitals in it. So we should just reassign that back in. Typically, these things don't want to change the original unless you decide to change it like I did there. So what we really, and I think we can even just tack it on there. Lowercase it and assign it to line. Maybe you don't like that. You can do it like that. Okay, so reassign it. Okay, so all lowercase letters gone. Don't know if that's really what we were doing here, but it's a good time to do it. Now we want the last word. Okay, so we're back here. We're back to the methods. What method would match here? This is where you might need to really kind of be reading through. We've used this one before. I think it comes up a lot, split. So there's different versions of it. It's this one here. Return a list of words in the string using separator as the delimiter. Okay, so a delimiter is a thing that we've maybe talked about, but the delimiter is the thing that shows us what marks the separation between words, I guess is what I would say. Delimiter is the thing that separates one word from the next word. So if we split this down here, same thing is going to happen. We don't change line, but what we get is a list of each of the words when they're separated by their spaces. Okay, so, and now if you remember your indices, like if I put an index of 2, we get 0, 1, 2. We'll get the word well back. Okay, but what we want is the last word. Well, we could count how long this list is and minus 1 from it, but you might remember that actually minus 1 is an index that counts backwards and will get us the last thing in the list. Minus 2 will continue, so useful, right? But all we need is the last word. So last word is that line split, right? And then the last thing in that list that it created sent back to us. So if we go in here, we should have a last word from that. Okay? So let's turn it into a function. I think that's all we need to do. Last word. Last word. We're passing in a line. And you can kind of see I'm kind of keeping these somewhat consistent. I guess I just can call it word for now, and I will return it because of course that's always super important. So print last word of the line. Did I get rid of my line? I think I did. The line was, but you know, it's never a bad idea to test it with more than one line. So that would be something you could do. All right, so there comes out the last word. And if there was a capital R in there, well, we've dealt with that too. Okay, so last word is done. So problem 2 is finished. We could find the syllable of the last word as well. So this thing will give us the last word. And what is that when we dump that into our syllable, last syllable? Now you might be saying, this is crazy. How was I supposed to know how to do all these steps? And the steps really are, you know, come out of trying to solve the problem in a kind of small problems one at a time. So I think you can solve the subproblems. I think the problem is that if you don't tackle it in that way, then it becomes a problem. So it found ACH for this. So we are well on to solving this problem. We haven't read any input in. It might be time to do that because we're kind of at the point where we don't have anything to work with when we want to look at the patterns of the matching. So we're trying to find the syllables for each line. So I think it's time to take that step. So let's just deal with this one to start. And I always like to paste it into my code and kind of see what I'm dealing with. So triple quotes. Okay, so we know that this is the number of 4-line chunks of a poem that we're going to get. And they called it, I think they called it N. So, oh, sorry. Oh, this is, yes, so here, the first line contains an integer N. It's between 1 and 5. That's not too important. We don't really care about that, but we'll see in a moment. But I find it's actually useful to keep their variable names, because when I switch back and forth between the problem, I don't have to like, oh, but I called that number of lines and that they're calling it n. I don't need to switch back and forth. So I just call it the same thing whenever possible. So capital N, okay, fine, capital N. Normally wouldn't use a capital, but that's fine. And it's just going to be an input that we then turn into an int. They said it's an int. They're guaranteeing it's an int. So fine, we'll just read that, okay? I'm going to put the functions up at the top so they're actually kind of available to us. Python needs them to be defined already, so we're really working here. All right, so we read this number, we turned it into n. That is the number of 4-line, what do they call it? It's not a poem, but it's let's see here. This is getting tangled up. Verse, the number of verses. So that's a verse. Number of 4-line verses. So that means we have to read in 4 lines. We know that because each verse is 4 lines. So let's just ignore n for a moment. I know that sounds strange, but let's just read in a 4-line verse. We know in this case it's going to be 1. We're going to throw this one at it. So let's just grab the line each time. So what we need to do is we need to read in 4 times. Now I want to use a different variable than n. That's not going to be a good idea. So we could use m. It's really just a throwaway variable. I just want to do something 4 times. I want to read in a line. Let's just print it out. That's enough to kind of get us started. Let's copy this, paste this in there. And what did we get? Well, we pasted in 4 lines, but it's hard to read here, but we're actually, and I'm printing out some other stuff here, so the order is really hard to kind of understand right now because it doesn't, I don't think it kind of deals with this. As I pasted it, it was printing stuff out. So I pasted in the first line and it pulled it out and printed it. Pasted in the second line, it pulled it out and printed it. I pasted in the third line and it printed it. Each time I paste, there is a new line character on the end of these lines. This one, for some reason, doesn't have the new line because I think it's the last one I copied. So I didn't copy a new line character. So I have to hit enter, and then it reads it in and it prints it out. So that's actually printing out the things we're looking for. And let's not print that. Let's just print this. Let's go back to what we said here because this is actually ready to go, working for us. What are we printing out? The last syllable in each case. So again, same thing. Last syllable is not that line, last word line. What did I do there? Oops. That was not what I meant to do. Someone was thinking that. I'm sure many of you were thinking that at some point. I had defined line and forgot to take it out for our function version. Small, all, ought, not. This is working. Okay, good. So in this case, we're getting the last syllable each time. So now last syllable is a function, so you know what? I think I will use a list. Let's just start a list that's going to, I'll just call it a poem at this point, and it's going to be an empty list. And each time I get this last syllable, I'm just going to append it into the list. You might not like the way this looks because this is like too many brackets going on, but I'm really just keeping what we already know works. This gives us last syllable, so I'm just appending it. You could assign it to a variable if it makes it more understandable, but and I think the other thing I can say is that you can copy this by just doing that. So that's paste. So what is our poem? It is the syllables all, ought, all, ought. Okay, we've dealt with reading. This should work. This doesn't work yet for n number of verses. Okay, so let's just come back to that in a moment. Let's just deal with this one test case for a moment because I think it's going to remain more understandable. We actually need to print out the rhyming scheme per verse. So we'll just try to finish per verse. I know this video is really long, but I hope it's going to be useful because I think I've left it for a few days for you to struggle with, and I hear that people are still struggling. So what is the rhyming scheme to this? This is we've cracked this. I think at this point we're pretty much at the end of it. We got to come up with these. So I'm going to paste that in again. I delete this stuff, later, but right now we have a let's look for a perfect. So if poem, we have a list, okay, and this is the first syllable, this is the second syllable, this is the third syllable, this is the last syllable. If they're all equal, then our code is supposed to output perfect, exactly like that. No Double check that. You can even copy and paste them in. You know what? It's not a crazy idea to do that. In case of a single word, I think I can do it, but you see spelling mistakes all the time, other things like that. If it's a multi-line thing, you should paste it. Let's keep going. So, else, if. So we just did perfect. I'm going in order here. I'm going to come back to that in a moment. Even, poem, even, first two lines. First line. You can stop the video and do this yourself at this point, I think. First two lines and the last two lines. Lines. All right, that is even. And we continue. But I just want to say something before I continue. Something really crucial here. We just lucked out on this because I'm following these lines. But actually, I should be thinking very carefully about this because bad things will happen in some cases. We're trying to chain together several if statements. Where have things gone wrong before when we do an if statement? Even though we seem to be writing the correct stuff, sometimes we encounter these situations where order matters, right? What is the problem with order? We have to think clearly about this. I kind of wish they had given the problem statement differently because they solved it by giving it to us in the right order. We actually looked for perfect first. If I switch this around, I know the syntax is wrong, but if I switch this around, if I had a perfect poem, would this still be true, is the question. Well, of course it's true, because in the case of a perfect poem, they're all equal. So in the case of an even poem, right, that we fed it, if we fed a perfect poem into this if statement for even, it would be true because they're all equal. So this part of the statement would be true, and this part of the statement would be true, and the end, of course, would make both of them true. And we would, if we fed a perfect poem into this if statement and checked even first, then it would come back and say that the perfect poem is in fact even. So we have to actually check, I would say, the most special cases first. Any case that could be construed as true by other statements, this can look at a perfect poem and think that its condition is true, even though it's not supposed to be even. I hope I've explained that in a way that makes sense. So we have to look for the most special cases first. That might not be clear at first. We might not even know. But that is a source of like some very deep kind of bugs that would be hard to find out, because when the judge will start telling us that we're making mistakes, but we don't know where to look and we don't know what the input is that it's feeding it. So it would really confuse us if we hadn't really thought about this beforehand and the judge just started saying, no, you're wrong. Right? So this is something that happens all the time. Students will say, I wrote my code right. I ran it on the test cases. It's working, right? But the judge, something's wrong with the judge because it's telling me it's not right. And it's almost invariably, it's one of these like things we didn't think of. So cross is first and third, and second and fourth. So second and fourth is that. And shell is first and fourth, and second and third, second and third. And then if it's none of those, then it defaults to free. Okay, we're getting close. So let's run this. And let's put back in the one verse example. All that's left to do is cross. Small, not tall, not small. So it's 1 and 3, 1 and 3, and second and fourth. So we're looking good. And we are not printing out anything now except for the answer here, the answer section. So categorize verse. There's no reason why this couldn't go into a function as well. It could even print from the function. It wouldn't be a bad idea. And the only okay, I'm going to get rid of this. I think I'll do that. It's just so easy to get lost in your own code. Def category verse. I don't know which poem scheme. Okay, and we pass in the list. It's really just a reference to the list, but I'm not going to get into that today. And so it's going to print it. Let's just return it because it's actually not a... We could have left it as print. I don't know. It's just way more... It's just not a bad idea to do it that way. Okay, so scheme, or get scheme we could have called it. So here we created the poem, and here we are just going to print the scheme. Doesn't that look so much better? I mean, really, that's like the whole point of functions part 2 is we are not getting lost in our code here now. Like, that was a lot of lines to confuse us. What the heck was going on? What point are we at? No, just, we don't even need a comment at this point, I don't think. All right, so we built up our poem. Oops, don't do it in the for loop. Wait until the for loop's done. All right, some comments would be actually a good idea. Process the verse. Okay, finish processing the verse. Print verse scheme. Okay, just think about like someone else coming in and having to figure out what's going on in your code. Man, my hard drive is going to fill up from this video. This is the longest one yet. Okay. We're missing one small detail, which is we didn't do this n times for x in range. We haven't used x yet. Could use O. I'm not sure what to use. It's just, we just want to repeat this n times with a new poem each time that then gets processed and put out. You could say, well, maybe this should be a function. I'm not sure. Maybe it would be, but I'm going to leave it as is because I feel like this is the core of the problem. When I was saying you just jump in and kind of try to attack the problem one line at a time, like from the beginning to the end of the problem. This is the code that does just that. This is get the input, do something the number of times it says, process each line, figure out and call our functions. But the hard part of the problem was in here. Well, this is also part of it, but in the end, I'm just rambling a bit. Let's stick with the test case that we did. Okay. And let's start throwing more test cases at it because our hope is that it's ready to deal with this. It printed perfect there and shell. Again, it's hard to see where these come out. So perfect and shell. You really should do your own test cases because there's going to be some test cases that the people who the even and free. So the CCC folks aren't like they're playing, they got some secrets up their sleeves still, maybe. They've still got some stuff that they're not telling us about. But at this point is the very first time I would suggest you run this on the judge. In fact, I would still suggest you maybe are running it with some poems that you've created at this point, This is really the beginning of it. So, but let's just throw it into the judge. And there's a very good chance that you'll see it come back with a problem at this point. But we've solved most of this problem at this point, and we're hoping it's Python 3. We're not going to have timeout errors. We're just going to have issues around whether we were correct or not. It was correct there, though. And it was correct because I think in a lot of ways we were very careful about how we attacked it, but we didn't go through the step of thinking of some more exceptions. So maybe in this case, and in terms of this problem, there really was no other kind of like tricky little things that could be tripping us up. if you made it to the end of the video, you really deserve some kind of prize. If you made it to the end of this problem without help, then you really deserve some kind of prize as well. But uh, but I don't have a, but you know, the takeaway is break the problem down and tackle it that way and test small tests. We're using Python, so we have the interpreter here. This is one of the reasons we're using Python. We could use so many languages, Java, C, whatever, but the one thing that we don't have in those cases is the interpreter. And the one thing that the interpreter is going to do is it's going to make sure as you write small chunks of code that what you're doing is what you think you mean to do. And it's going to prevent you from writing 50 lines of code with possibly 6 bugs in it that is going to be absolutely impossible to find. I mean, never mind whether or not you got everything else kind of working properly. Like if you have more than a few bugs in there, it's very difficult to solve those. So really following a process like this video is really a video about the problem solving process, I think would get you through to the end. So with that in mind, you might tackle this problem again on your own, and I will try to do videos for the other two. I'll try to keep them faster, but this is kind of, but good luck.